Hi, this is Mr. Max here. So this is my second video under the topic equations, expressions, inequalities, and identities. So I am doing today quadratic equations that involve some square roots. Now I have typed 4 of them here, so I'll suggest that perhaps you can pause the video now and then you can attempt to solve these 4 questions and then you see if you are getting any of them right. Okay, so before I get into solving or looking at those equations, I would want us to do just some quick revision on some basic stuff. The first one I want to look at is squaring a binomial. Now, so I have here minus 2x minus 8 squared and 2x plus 8 also squared, the quantity 2x plus 8 squared and the quantity negative 2x minus 8 all squared. Now, one of the things that you should realize when you are squaring a binomial or any number for that matter, even if it's a negative number, when you square it, you should get a positive answer. And if you square this one here as well, you should get a positive answer. So these two things in a nutshell are going to be giving you the same expressions. Okay, so this is basically what it means when you are writing it out like this. And I hope you still remember how you can multiply. Basically, you should arrive at 4x squared plus 16x plus 16x plus 64. You can see that that's twice the value of the product of that. So eventually when you clean it up, it gives you 4x squared plus 32x plus 64. You're going to get the same if you do the other one. So for this particular case here, if you're squaring any value, as long as that value is positive or negative, you expect to get positive answers. Now let me go back to squaring a binomial. So I bring in something like 2x plus 5 all squared, that quantity there. Right, so according to what I have here is that you square the first term, so you square the 2x squared. Now when you square 2x squared, you're going to get 4x squared. And then you take the product, twice the product of the two terms, that is 2 times 5, obviously there's an x attached to that. So 2 times 5, which is 10, times 2, which gives you 20, so it should be 20x. And you will surely get that if you do this long way where you take the 2x plus 5 and 2x plus 5. Because remember, it's that 2x times the 5, which gives you 10x, plus another 2x times the 5, which gives you another 10x to give you this 20x here. So if you look at the 16x and 16x, it basically comes to that same concept. When you are multiplying, the minus 2x times negative 8 gives you 16x, as well doing it again. All right, then the last part to this is going to be you square, simply square the last term. That is why I wrote plus here, because remember what I said, anything that you square becomes a positive. So 2x plus 5 whole squared basically gives you nothing but 4x squared plus 20x plus 25. So you should be familiar now on how to square binomials. Let me bring in one or two more other quick points, that a couple of points really that I also want to clear. A square root and a square are reverse operations of each other. So if you take the square root of a all squared, you're just going to end up with a. You can check it by putting any value for a, maybe on your calculator if you want to. The square root of 5 squared will give you 5, for example. Another thing is, suppose I have some square root that is squared like here, but now I put an expression under. Again, simply using that property there, you know that the square root and the square will cancel each other out, leaving you only with 3x or 3 minus x. Let's come back to this concept of squaring the first, taking twice the product of the two terms and squaring the last. When I give you something like this, so here I've got the property or the quantity, the square root of x plus 7. Think of that as just one operator. Or plus 2 all squared. So again, applying what we know from this, I will square the x plus 7, which is under the square root. So once you do that, obviously the x plus 7 will just be on its own without the square root. Then we said, I'm saying plus twice 2 times that quantity there, x plus 7 in the square root. then adding 4 coming from 2 squared. And when you clean that up, you're going to eventually end up with x plus 11, and that is the x plus 7 plus that 4. So 7 plus 4 gives you the 11 plus 2 times the square root of x plus 7. So you're going to get these type of things when you are working on those equations that I gave you, where you need to be able to remember this so you can see how I went about getting to those solutions of those equations. All right, so let's start with the very first equation. So the first equation you're supposed to solve for x is the square root of 4t minus x squared equals to 3x. Right, so I'm going to go ahead and take square both sides, and that's going to leave me with 40 minus x squared on the side equals to 3 squared and x squared, which is 9x squared. It's very important that you square everything there. This is becoming rather a very straightforward equation where you have 10x squared is equal to 40. While you have two terms, you can definitely find it to be x squared minus 4 equals to 0 because it's quadratic. You should also be able to realize that x is going to equal to positive or negative 2 when you solve for x. Now, before you just go ahead and accept that those are the solutions, remember you are dealing with square roots. And it could be tricky what you're going to get comparing the left-hand side with the right-hand side. So that means you need to check your solutions to see that if x is equal to 2 when you insert it on the left, do you get the same result when you insert x on the right-hand side, for example? So I have done it here when x is equal to 2. So if I insert it on the left-hand side, I get 6 as an answer. That's 40 minus 2 squared under the root sign. And if I also do it on the left-hand side, or it could be the right-hand side if you look at it this way, you have got 3x. 3x is nothing but 3 times 2, which gives me 6. Right, so x equals 2 is definitely a solution because what you put in the left for x is going to give you the same what you put on the right. So the left-hand side is equal to the right-hand side. So you need to do the same for x equals to negative 2. So I have done that. And once you do that, you will realize that negative 2 is not the solution to this particular equation. Because if you put negative 2 in here under 40 minus x squared under the root here, you're going to end up getting 6 as an answer, as we have already determined. But if you take 3 times negative 2, you get negative 6, and the 2 are not the same. Therefore, x equals to negative 2 is not a solution to this particular equation. So remember to check your work whenever you are doing equations that involve square roots and all other quadratic equations for that matter. The second one that I have here, a little bit tricky, but not that much. The idea is you want to isolate the square root. So you're going to add 2 to both sides of the equation. And once you're here, you're going to square both sides again. I know it could look like complicated, but just follow the steps. And I hope you remember from that quick revision that you're going to end up here with t squared plus 4t plus 4, square the first, square the second, times twice the product of these two in the middle. And on this side, the square root and the square just cancel each other. So now you're going to have to rewrite this in quadratic equation format. Right, now you have t squared minus t minus 2 equals to 0. So this is going to factorize if I do that. You don't have to use completing the square method or the quadratic equation formula or whatever you want to use. In any case, I get answers for t is equal to negative 1 or t is equal to 2. Remember I said we are not completely finished here. So we need to check again what answers are we going to get when we put in for t equals negative 1 or for t equals to 2 on both sides of the equation. Now, when t is equal to negative 1, you realize that on the left you get negative 1, obviously. On the right, you also end up with negative 1. Therefore, t equals negative 1 is a solution to this equation because the left-hand side is equal to the right-hand side. But what about when you input for t equals to 2? Now, I have done it here. Obviously 2 on the right or on the left would be okay. But after you put it in here under the square root and you work it out, you get 2 as well. So therefore, t equals to 2 is also a solution to this equation. So both these values then are acceptable answers as solutions for t. I have the third equation. Very similar like that one, but here now you have a problem. You have a square root on the left, and you have a square root plus some other term on the right. So go ahead and just square both sides. Right, so before you attempt to do this, remember by now I expected you to subscribe to my channel. So if you haven't, please subscribe. And then you click this notification bell so that you can get an update every time, a notification when I upload videos. Because remember what I said, it's a long road and we are going to work quite a lot. Right, so this is going to be, if you square both sides, this is going to give you nothing but 3 minus x on the left. And on the right here, you're going to have, now you have to be very careful when you are doing this. This square root of x plus 7 just becomes x plus 7. Then twice the product, there 2 times 2 times that gives me the 4 square root of x plus 7. And square the last term, plus the square of the last term. Right, so I'm going to clean this up now. I've done this something similar when I was doing the quick revision for you to be able to see. Bottom line, let's rewrite it and just clean it up some more. So I'm going to be ending on this side with minus 2x minus 8. I put it in brackets. And 4 square root of x plus 7 should be 1v1. Now when you're here, go back again and square both sides. So when you square this, the x plus 7 will be there, but 4 squared, remember, is going to give you 16. And then you simply then rearrange and have your equation to give you 4x squared plus 16x minus 48 is equal to 0. So make sure that your algebra is very sound, that you don't make mistakes with signs, because it can really throw you off. And another thing that you must realize by now here, don't just grab and rush to solve things by using formulas. For example, the quadratic equation formula. When you look at this 4x squared plus 16x minus 48 equals to 0 expression, or this quadratic equation here, you can see that 4 is a very common factor. So you can divide both sides of the equation by 4. In order for you to simplify it a bit, that gives you x squared plus 4x minus 24 is equal to 0. Surely you should be able to factorize something like that. Again now, so when we solve them for x, you get x is equal to negative 6 or x is equal to 4. But remember, we're not completely done now. We are now supposed to quickly do a check. You can do this quickly with your calculator in any way, just to see if x equals to 6 or if x equals to 4 are solutions to the equation. Are they both solutions, or are they both not solutions, or is it only one? Right, so on this slide here, I have done the first when x is equal to negative 6. And when I put it on the left side, I get a 3 as an answer. If I put negative 6 on the right side, I also get 3 as an answer. So x equals to negative 6 is a solution, as the left-hand side is equal to the right-hand side. But when I put x equals to 4, using the same reasoning, I'll get on the left side an answer of the square root of negative 1, which does not exist in the set of real numbers. So I don't even need to go further with my check, because this does not solve. But then, interestingly also, if I was to do it on the right, I get square root 11 plus 2, which is totally a different value, irrational number. But so x equals to 4 is not in the solution, because you are not going to get an answer, because the moment you put x equals to 4 under the root sign, you get a negative answer, and the square root of negative 1 does not exist in the set of real numbers. This brings me to the last question of the 4 that I gave you. It looks a little bit tricky, but one of the things that I want you to be on the lookout is for any fraction, and we have an unknown that is part of a fraction, we know that the denominator can never be equal to 0. That's one of the things, right? So if you have any fraction, and the fraction is vulgar, a over b, we say that that b should never equal to 0. Then it's possible then to calculate. So in this particular case, I have the square root of 3y minus 1. Whatever that answer should give me, that answer should not equal to 0. So the answer should be greater than 0. But the reason why sometimes we can also consider 0 is because the square root of 0 is nothing but 0, which is a value we can work with. But in this case we can't, because the moment we put 6 over 0, you cannot continue with that particular question. So you will see me first doing this in order for me to already determine, before solving whatever method I'm using, the equation as to what y should not be, what I should avoid. Okay, so it's very important that when you're dealing with square roots that you consider that particular quantity or property. So on the side here, I've taken that step. I said square root of 3y minus 1 should be greater than 0, because if I have it less than 0, it gets a negative. But under the square root, you can't have a negative value. So I'm looking for positive values. 0 can work, but not in this particular case because it is part of a fraction. Simply said, you can have a 0 here as an answer. You can get that answer, but you won't get it on the left side of the equation. Right, so if I go and I clean it up, now the way I get to 3y minus 1 is greater than 0, I'm squaring both sides. The square of 0 is just 0. So what I'm looking at is y. If I go and solve this equation, I must consider values that are greater than 1/3. So if I get 1 over 3 as an answer, I will also not consider it, besides my normal checking that I'm going to do towards the end. If I get such a solution, I'm not going to consider it, because the moment you input that here, you're going to get a 0, which will make this fraction on the left to be undefined. Right, so let me go ahead and use a simple method. So what I like to do is I like to take the square root. It looks a bit messy, but I will just say let that equal to some k, any letter you can use. And then I will rewrite it now as 6 over k equals to k plus 1. It looks a little better, don't you agree? Right, so then let me just quickly bring in a bracket here. And from here you can consider this as cross multiplication. The idea is you want to clear the fraction. That gives you k squared plus k is equal to 6, which becomes k squared plus k minus 6 is equal to 0. It's a quadratic equations. They should always equal to 0. This factorizes definitely to k plus 3 and k minus 2. So k, therefore, if you solve it, you get k is equal to negative 3 or k equals to 2. But I'm not looking for the values of k. I'm rather looking for 3y, the square root of 3y minus 1. So I'm going to substitute it back for k. So in the first instance, I have the square root of 3y minus 1 is equal to negative 3. Put it in brackets, because remember, you're going to get rid of the square root by squaring both sides. And that whole negative 3 should be squared and it becomes a positive number. If not, you will deal with a negative number and you might make mistakes. Similarly, then you do that also with the square root of 3y minus 1 is equal to 2. Eventually, you get 3y is equal to 9 plus 1. Or 3y is equal to 4 plus 1. So I'm going to continue on the next slide, but you can pause here and see if you follow the steps that I have applied here. Because right now I'm looking for the values of y. Right, so I get y is going to equal to 10 over 3, or y is equal to 5 over 3. And I also know that y should be greater than 1 over 3. So all of these therefore make sense for that part of the constraint. So these two solutions have to be checked the traditional way, like I was doing the other ones, to see if both of them are rather solutions to the equation. And I also know they conform to being greater than 1 over 3. So I'm on safe side as far as the square root is concerned. Right, so you still have to check. So I was checking y equals to 10 over 3 on the left. Once you put it on the left, you get a 2 as an answer. But you put it on the right hand side, you get a 4 as an answer. So y equals to 10 over 3 is not a solution for this equation. What about y equals to 5 over 3? Well, I've got the answer. When I do it on the left, I get a 3 as an output. When I put it on the right hand side of the equation, I get a 3 as an output as well. Guess what then? Yes, y equals 5 over 3 is a solution to this equation, as the left hand side is equal to the right hand side. Right, so I'll suggest that you work on these things on a day-by-day basis as I continue and as I keep on putting up these videos. It's for your assistance with the course AS level.